Hey, today guys we're doing Unit 3, Day 1, Functions, Equations, and Graphs. So we're going to start out with our notes. So I have everything written out, so just follow along, copy down as you can, and then pause the video if you need to. So the first thing we're going to talk about is our domain and range. So this is kind of a review for you guys. So domain is all of our x values, and our range is all of our y values. So we'll be talking about that and identifying those throughout this unit. And then another thing that we're going to be doing is determining if our graphs are functions or not. So there's two ways that we can do this. So if we look at a graph, we can identify it by the vertical line test, which means we're going to draw in a vertical line. So if we're given the graph and we draw vertical lines, the graph may only touch the vertical line once. So we'll do a couple example problems like that, but that just means if the vertical line that we've drawn touches the graph in more than one spot, then it does not pass the vertical line test and it is not a function. And the other way that we can test if our graph is a function or not is to look at our x values. So if we list out all of our x values, we can't have any of those values repeat. So if they're all different, then it is a function. If it repeats, then it is not a function. In addition to those, we're going to be looking at function notation. So our function notation looks like this here. So we have f of x equals 3x plus 2. It's the same as saying y equals 3x plus 2. It's just written a little bit differently in our function notation. So when you see something like f of 2, all that means is that you're taking that 2 and you're going to substitute it in for the x and then simplify on the right side of the equation. So you're going to take this 2 and you're going to plug it in here, so then it becomes 3 times 2 plus 2. And the very last thing on the notes is our mapping. So what that means is we're given a list of ordered pairs, and we need to write out in order from least to greatest all of our domain, which is all of our x values, and all of our range, which is our y values. So once you do that, you have those in your box, then you just draw an arrow from the x value to the y value. So for example, our first one is negative 2, 8. So I draw an arrow here. Second is negative 1, 1. Third is 0, 0. Fourth is 1, 1. And the fifth is 2, 8. And that's how you would do the mapping. So let's get started on some of our practice problems. Number 1 says state the domain and the range. So the first thing that we're going to do here is identify our x and y values, and then we'll state the domain and range. So you're just going to go and count out your spots. So over 2, up 2. So this point is 2, 2. Let's see, we have over 6, up 5. This is to the left, so it's negative 4, up 6. And we have negative 3 and negative 2. So we've identified all of our x and y values. So now we need to just put those in order. So domain is going to be all my x's. So my domain is going to go, again, smallest to largest. So we're going to start with a negative 4, negative 3, 2, and 6. And our range is going to be all of our y's. So we are going to start with negative 2, 2, 5, and 6. Same thing for number 2. It's asking us to state the domain and range. So again, we're just going to put them in order. If it's easier for you to rewrite them out first, you can. I'm just going to underline so I know all of my x's that I'm looking at, and then I'll circle all my y's. So my domain starts with my negative 8, and then my negative 3, then it goes to 0, 1, and 4. So that's my domain. My range is all my y's, so everything I have left over. So I start with a -2, a 4, 5, 6, and 10. So there's my domain and range for number 2. Flipping over to the back, number 3 is asking us to determine if the graph is a function. So if you remember back from your notes, we said that we were going to use the vertical line test to determine if our graph is a function. So I'm going to draw on a vertical line here, maybe draw on another one here, and then I'm going to circle how many places that line touches my graph. So this vertical line only touches it in one spot. This vertical line also only touches it in one spot. So it passes the vertical line test, so we do know that our graph is a function. So yes, this graph is a function. I'm going to do the same thing for 4, and right away I can see draw my vertical line, and it touches in more than one spot. So if my vertical line touches in more than one spot, it is not a function. 5 and 6 ask us to determine if it's a function as well. So remember, we are looking, if we don't have a graph, we can look at our x values and determine if there are no x's that repeat. And if that is the case, then it is a function. So we'll look at our 5, our -6, our -3, and our 1. And none of those repeat. So the answer is yes, it is a function because no x values repeat. And let's look at 6. We're going to do the same thing. We're going to look at our x's. We have a -2, a 6, a 3, and a -2. So our -2 repeats, so it is not a function. There is an x value that repeats. And then the last 2 problems, we're going to evaluate the function using, we have f of 2, f of -3, and f of 1/2. So that means we're going to take all 3 of those numbers and substitute it in on the right side of the equation there. So I'm going to grab a different color pen so you guys can see when I solve these different problems. But all I'm going to do is take my 3x minus 5 and substitute that 2 in. So I have f of 2 equals 3 times, and now I'm going to plug in that 2 minus 5. So this f of 2 doesn't mean anything. It's just telling us what we're substituting in. So do not worry about solving anything on that side. So then this becomes 6 minus 5. So f of 2 equals 1. And that's it. So I'm going to do the same thing with -3. So I have f of -3 equals, so I'm going to take 3x minus 5, and I'm going to put in my notation 3 minus 3, or 3 times -3 minus 5. So that becomes -9 minus 5. So f of -3 equals -14. And then the very last one is f of 1/2. So f of 1/2 equals, I'm going to go back to my original equation again, 3 times 1/2 minus 5. So 3 times 1/2 gives me 3/2 minus 5. So my f of 1/2 equals -7/2. So that's all we do for our piecewise functions there. So let's do the same thing on number 8. Looks a little bit different because we have a quadratic. So same thing again though, all we're doing is taking our values. So we have 2x squared minus 4x plus 1, so we're going to start with f of 2. So we have f of 2 equals 2 times 2 squared minus 4 times 2 plus 1. So we're going to do order of operations first, so we're going to do 2 squared. So that becomes 2 times 4 minus 4 times 2, which is 8, plus 1. And then 2 times 4 becomes 8. So it's 8 minus 8 plus 1. So our answer is 1. Same thing again for f of negative 3. Two times 3 squared minus 4 times, negative 3 squared, negative 4 times negative 3 plus 1. So negative 3 squared, negative 3 times negative 3 becomes positive 9. So I have 2 times 9 plus negative 4 times negative 3 becomes positive 12 plus 1. So 2 times 9 is 18 plus 12 plus 1. That gives me 31. 18 plus 12 plus 1. So f of negative 3 equals 31. And then the last one is f of 1/2 equals 2 times 1/2 squared minus 4 times 1/2 plus 1. So 1/2 squared becomes 1/4. So we now have 2 times 1/4 minus 4 times 1/2 becomes negative 2 plus 1. So 2 times 1/4 gives me 1/2 minus 2 plus 1. So my final answer comes out to negative 1/2.